This is the problem number 2 about stress, and we are still applying an axial load, but this time to a system of tubing. So let's look at this problem. We have two pipes that are welded together, okay, and we have some load that is applied just there, just on the little border, so just on there, on this surface, and we have a load that is applied on the bottom. Okay, so the question is, oops, let me re-add the forces PB and PA. So the question is, what is the stress inside the pipe? And we will see also if the dimensions of the pipe make sense. Okay. So what is the first steps? I know we kind of skip this step in the first problems, but first steps is always free body diagram. Okay. So let's do a free body diagram. We have the smaller pipe on the top and the larger pipe on the bottom. Okay, so this is empty. Up. I don't like I should do this and this. So you can ups something like this and something like this. Okay, so it looks like this. If we add the forces that we know the PB on the bottom and we know the PA there. Okay, this is just one time PA. Let me write it just one. It's applied all the way around, but it's just one time PA. And the question will be to find the forces in the tubing 1, so here, and in the tubing 2. Let me write tubing 1 and there tubing 2. So because of that, we will need to do free body diagram of different parts. I will need, if I look at just the top part of the tubing 1, I need the free body diagram, the forces on the top. So I have PA and PB on the bottom. So on the top there, I need to have PA plus PB. Okay? So now, if I cut the tubing 1 and I look just at the top part of the tubing 1 like this, I have the forces that I know on the top, PA plus PB. So where I cut here, I also have PA plus PB. Okay? So that will be for the tubing 1. Now if I look at the tubing 2, let's use the bottom part, it's a bit easier. So I have the bottom. I know I have PB on the bottom. So I have also PB on the top. So you see why it's important? Because the force, the axial load in each pipe is different. Will you have guessed that? Even if they are attached together? Make sure to do your free body diagram and make your equation. So now we know the force and we can work on our sigma, our stresses. So pipe number 1, the top one, okay, we are looking at here in the pipe. We have sigma 1 will be equal to the total force on the surface, so PA plus PB, and divide by the surface there. What is the surface of this one? That will be the surface of the outside circles disk minus the surface of the inside. So P, the outside is 40, so P4 divided by 2 square, because that's the radius that we need, minus the inside, that will be pi times 3 divided by 2 square. Okay, so your sigma 1 in your pipe 1, so PA, in our example, we will take PA equal 1500 Newton and PB equal 2000 Newton, like this. So we will have, make the calculation, but 15 plus 2000 divided, okay, the surface for the first tube, I got a total of 550, about 550. Keep your exact number if you can. So sigma 1 equal 6.37 megapascal. Okay, that's for the pipe number 1. Now we do the same for the pipe number 2. Okay, sigma 2 equal, and this time the force that is involved in this one is just PB, be careful, the bottom one has just a load of PB equivalent to PB. And we need now to look at the dimension of the bottom pipe. So pi, sorry, divide time the diameter divided by 2 square minus the inside, that is the pi time 35 divided by 2 square. So we got sigma 2 equal PB is 2000. The surface of the pipe number 2, I got 628 millimeter square, so sigma 2 equal 3.18 megapascal. Okay. So here are my answers. You see the stresses in the pipe are very different. What do you think about that? Does that make sense? I mean, it makes sense because the pipe number 2 is submitted to a lower load and also is larger. So in this case, what we will try to do is we want to have the sigma about the same. So we will need to adjust the size of the pipe. Okay? Maybe the first pipe is a little bit thicker and the second pipe is a little bit thinner. So at the end, we can use the same materials for the both pipes and get the same stresses all the way over the system. Right now, the upper pipe is submitted to twice the number of stresses than the bottom pipe. So, that makes sense. Okay, so sigma 1 is way bigger than this one. I'll let you work on that on your side. Bye-bye.